I will be going over fluid power systems. Fluid power is pressurized liquid or gas that does work in a system. The two common types of fluid power used in industry today are hydraulic and pneumatic. When drawing fluid power systems, you have three types of lines that you'll be using: a main line, which is your main source of air or fluid; pilot line, which is a secondary fluid that has already been acted on by another component; and a chain line. A chain line represents an enclosure. For example, we have a flow control valve here. A flow control valve has two components, a needle valve and a check valve, but it is in one housing. There are two components in there, but it's in one housing. That's why we have a chain line around it. It shows that multiple components, or however many are in the chain line, is in one piece or one part. Flow control valve is made up of a check valve and a needle valve. A check valve limits the direction air can flow. For example, in this one, the air can only flow down this way and not the other way. A needle valve is a small orifice that has a needle in it. It looks about like this on the inside, and it is adjustable by screwing this portion of the flow control valve up or down. That limits the size or volume of the air that can go through that orifice, which will limit the speed of whatever component is on the other side, usually a piston or a double-acting cylinder. In hydraulic and pneumatic systems, we have DCVs, or a directional control valve. That is a valve that changes the direction of the airflow. An example of that would be a push button, a 3-2 push button, meaning the air would come in here and you would press the button and it would change the direction it flows. DCVs are labeled by the number of ports and the number of states it has. This would be a 3-2 because it has 3 ports and 2 states. This 5-2 impulse valve is a 5-2 DCV. It has 5 ports, 1, 2, 3, 4, 5, and 2 states, this one, this one. So it's a 5-2 impulse valve. DCVs are used with control mechanisms. Those are what we draw on the outside of the box for this, which is a push button with a spring return. The control mechanisms are the push button and the spring. On a 5-2 impulse valve, the control mechanisms are our impulses of air, pilot air, on this side and this side, or 1 to 2 and 1 to 4. On a 5-2 impulse valve, we have these numbers over here, 12 and 14. It really means 1 to 2, meaning in this state you have air going from 1 to 2, and 1 to 4. In this state you have air going from 1 to 4. When we draw DCVs, a little T symbol over a port means it is a closed port. No air is going in or out of that port. If there is a hollow triangle here, or sometimes you'll see it on the end of a line, it means it's exhaust. That's for air to be vented to the atmosphere. In hydraulic systems, it will return to reservoir. In pneumatic systems, the air is vented to the atmosphere. The arrows in a DCV represent the direction and placement of the air. So from 1 to 2, the arrow is going to 1 to 2, pointing towards 2, meaning your air flows from 1 to 2, not 2 to 1. And on this side, the air goes from 4 to 5, as represented by the arrow. In hydraulics and pneumatics, we typically use PSI, or pounds per square inch. That is our unit of pressure that we use. At the beginning of every pneumatic system, we tend to have a FRL, or filter, regulator, and lubricator. We also call it an ACU, or a trio, or ASU, not ACU. This is the best example we have of an FRL. It does not have a lubricator. It only has the filter and the pressure regulator. The filter removes contaminants from the system, which is good because getting contaminants in your system will damage delicate parts, clog ports, and just cause mayhem. The regulator limits your pressure so you don't break parts by having, because your main air may be at 120 PSI, but your system needs to run off of 60, so that's why you have a regulator. A lubricator puts a small mist of lubricant into the system that helps lubricate moving parts and increase the longevity of these parts. That is everything.